interconnectedness between roots, factors, and the graphs of not only quadratic equations, where we have an x squared term, but also of all polynomials. I can do this fairly abstractly without having a specific equation in mind. I can look at the graph and determine what its roots are, and then determine what its factors are just by looking at the graph. So let's say I have a parabola that looks like this. Okay? I know that it has a root there and a root there. Just for argument's sake, let's say this is 1, 2. Let's say this point is 2.2, and this point is minus 0.5 on the x-axis. So now I have an x value, an x root at negative 0.5, and I have another x value, a root, at 2.2. This means I actually have factors to make up this polynomial, to make up this parabola of x plus 0.5 times x minus 2.2. And the reason for that is we know that these two, either one of these, when they're equal 0, the whole polynomial equals 0. So if x plus 0.5 equals 0, we know that the polynomial, the parabola here, equals 0. So we can determine roots. We can determine roots from factors, and we can determine factors from roots. Okay, let's look at another example. This time we'll actually consider a polynomial. F of x equals x squared plus 6x plus 5. Now, we know that we can factor this as x plus 5 and x plus 1. And if we set f of x equal to 0, we know that either x plus 5 must equal 0, or x plus 1 must equal 0 in order for this to equal 0. Because if one of these two equals 0, then the whole expression, the whole equation will equal 0. So if x plus 5 equals 0, x equals negative 5. If x plus 1 equals 0, x equals negative 1. These are our roots. But x plus 5 and x plus 1 are our factors. I hope this is helpful.